In this lesson, we are going to be factorizing difference of squares. So what are difference of squares? Well, what you need is the following. You need two terms. Okay, they must be separated with a negative. Separated with a negative. Okay, and then each term is a perfect square. Each term is a perfect square. So for example, if we say x squared, take away 25. And by the way, if any of these don't make sense, I'm going to make them very clear as we go through. So have a look here. We've got two terms, 1, 2. Okay, so that's correct. Are they separated with a negative? Yes, they are. And is each term a perfect square? Well, what do I even mean by perfect square? Well, we know that to get x squared, you would say x times x, and to get 25, you would say 5 times 5. So when these two things are the same, and when these two things are the same, those are called perfect squares. Where do we get the name perfect square out of interest? Well, if you imagine a square where both sides have a 5, if you had to work out the area, you would get 25. That's why we call it a perfect square. Whereas if it was a 4 and a 5, that's not a square, that's a rectangle. That's literally where we get the word perfect square from. If you had an x and an x, because these two would have to be the same if it's a square, then it would be called x squared if you get the area. So you see, so that's what perfect squares are. Okay, so for example, another perfect square would be a 4, but because it's a square, all the sides are the same. So if you had to get the area, that would be 16. So we can say that 16 is a perfect square. Okay, so yep, this is a perfect square. Okay, and so if you have a situation where you've got two terms with a negative and each one's a perfect square, then what I'm going to be doing in this lesson is showing you how to factorize that. It's very easy. Okay, so here's our first one. So let's go through our little checklist. Number 1, do we have two terms? Yes, we do, because there's 1, there's 2. Number 2, are they separated with a negative? Well, I don't know about you, but I can see a negative there, so yes. Now, is each one a perfect square? Perfect square? Yes, because 4r, imagine you had a square, 4r and 4r, if you had to get the area, that's 16r squared. And then if you had a square with 1 and 1, if you had to get the area, that would be 1. So we have got two perfect squares. Okay, so how do we factorize this? What you do is you make two brackets. Put a plus in the one, put a minus in the other. It doesn't matter if you maybe want to switch the order. Maybe you want to put a minus in this one and a plus in that one. That does not matter. Okay. Now what you do is you literally just take this the square root of this. So if 16r squared is the area, then 4r is the square root. So we'll say 4r and 4r over there. Then what's the square root of 1? It's literally just going to be a 1 and a 1, and that is the answer. That is all you need to do. Now, something I want you to keep in mind as we progress through this lesson is that you must always look out for a common factor first. There is going to be some of those in this lesson where you're going to have to take out a common factor before you jump into the difference of squares. Okay, that's a good you must always look for common factors. Whether you are factorizing trinomials or anything, you always look for a common factor first. And I'm actually just going to keep reminding you on that. Okay, so here's our next example. Let's look for a common factor. There isn't one. Okay, so the next thing is you would think, okay, maybe it's a difference of squares. So let's go through our steps. Number 1, do we have two terms? Yes, we do. So it's not a trinomial, because that is 3. Number 2, do we have a negative in between? Yes, we do. And then number 3, is each one a perfect square? Well, let's have a look. 5b multiplied by 5b, if you had to say 5b multiplied by 5b, that would give you 25b squared. Okay. And then if you had to say 4 multiplied by 4, that would give you 16. So this is, these are both perfect squares. Okay, so whereas, for example, if this was like an 18, then you wouldn't be able to create a square where the area is 18. Like, what are you going to say? Like maybe 3 and... You can't. And you can't say 6 times 3 because that's not a square. Squares have the same sides. So 18 wouldn't have worked. But luckily it's not 18, it's 16. Okay, so go ahead, make your two brackets, put a plus in the one, a minus in the other, and then you're just going to take the square roots. So 5b and 5b go there, and then 4 and 4 go there. Do you want me to show you that this really does work? That this is actually the answer? Well, let me show you what happens. If you had to go multiply these out using FOIL, first times first would give you 25b squared. Then the outers would be those two, so that would be negative 20b. Then you've got the inners, which would be those two, which would be positive 20b. And then you've got the last and the last, which would be those. That would be negative 16. And then if you had to combine all of this, so if you had to cancel that, you'd see that they would cancel out. Look at that. And then you're literally left with 25b squared, take away 16. Okay. Here's the next one. Now, here we have a bit of a problem. So we have got two terms. We do have a negative separating them, but we do not have perfect squares. You cannot make a square where the two numbers give you 12. You could say 4 times 3, but that's not a square, that's a rectangle. So we need perfect squares, but then we are forgetting step number 1. What is step number 1 for any type of factorizing? Well done if you remember. Take out a common factor. The number 3 can go into both of those. So we're going to take that out as a common factor, and then you'd be left with a squared minus 4. Now, these are perfect squares. So what you do is you just leave the 3 there, don't leave it out, and then just open up your two brackets, put a plus in the one and a minus in the other. It must always be a plus in the one and a minus in the other. Never a plus and a plus or a minus and a minus. That's only for trinomials. Then you're just going to take the square root, a, and then the square root of 4 is 2 and 2, and that's the answer. Here's the next one. So take out a common factor first. The number 2 can go into both of those, so you take out the 2. Then you'd be left with 9x squared, and you'd be left with 4. Then what you do is you open up your two brackets, and the square root of 9 is 3x. Well, 9x squared is 3x and 3x, and then the square root of 4 is 2. So you put 2 and 2, put a plus in the one, a negative in the other. And here's our last example. So this is not a perfect square. 80, you can't find it. Neither is 45 actually, but then we need to remember, take out a common factor. So I think the common factor is 5. Now, if you had to say 80 divided by 5, that will give you 16, and then 45 divided by 5 is 9. Okay, so there we go. And so what happens now is we can go to our difference of squares. So we've got the two terms. They are both separated with a negative, and each one is a perfect square. So we open up our two brackets, and so the square root of 16 is 4, and n squared is just the square root of that is just n, and then the square root of 9 is 3, and then you put a plus and a 1 and a negative in the other.